Hey there, Emmanuel here from WebDevFuel, and in this video we're going to go over this article that I've recently stumbled upon. Go is a well-designed language, actually. And it is written by Matt Hall, so I'm going to leave a link in the description down below so you can take a look at this article and also all of the articles from this blog if you want to. In many ways, 2009 decided my future career. I was 13 years old and had just scored my first goal in a competitive football match, a lovely one too, with the winger finished by a powerful striker into the top left corner. Sadly, the talent scouts were missing that day. Whilst I was dreaming of Wembley, Go was announced to the world. Then it continues by saying that Go soon attracted a large following. People loved how simple it was, how optimized it was for web services, and the tooling like Go format. Every action has an equal and opposite reaction, however, and so it was with Go. People hated how simple it was, how it was just for naughty REST APIs, and the overzealous tooling. Now, I think that this is mostly overreaction from communities online, again, Twitter, X, mostly because those are not actually reflections of what happens in the real world. If you're working on a project, if you're a web developer, you have a job, most web developers don't really care that much about things with that much passion. So at the end of the day, all of these things are just tools. Go is a language, it is just a tool to build something. And if you like using Go, you should use it. If you don't like it, you should use something else. But I think that at the end of the day, a lot of people have very strong feelings, and I don't really think that they should have those strong feelings attached to things like a programming language, even though I love programming and I think that it is interesting to talk about these things and to debate which things are better, what things are pros and cons of, let's say, Go or Rust, for example. But I don't think that the fact that people go on Twitter or on X and sort of bash the language over and over again and say that everyone that writes Go doesn't understand programming, or you have to write a specific language to be a good programmer. If you don't understand why that language is good, then you don't understand anything about programming. I think those kinds of arguments are just silly overall, and they don't contribute anything to the web development community overall. And I love Go also because of this, what this says here, because it has very nice tooling and it is a very simple language. So it has 25 keywords, which is very easy to understand and memorize and start understanding the language. And it also has very cohesive tooling. So the Go format package is something that is used to format all Go code, and everyone across the Go community uses the same tooling to do formatting. We also use the same tooling to for example, run an LSP, even if you're, for example, using VS Code and you install the plugins. Even though you do that, you have the Go LSP underneath, so you end up using the exact same thing. And this also reminds me of the Go Please documentation here around Vim or new Vim. And this is something very cool because, as you can see, it is part of the Golang project itself, this repo, tools, and then we have Go Please, and then documentation on how to install it with Vim or new Vim. And if I scroll down here, we have here the imports, and this allows us to when we save a file with Go, it auto imports stuff. Again, if you're using VS Code, this happens automatically. But I wanted to show you this because it shows how cohesive the tooling is and also the documentation, because this is part of the Go Please repo here itself. So we have the tools and then Go Please, and here the vim.md. And we have here instructions even on how to install things in NeoVim and how to set things up to have auto importing and formatting. And this is, again, something very cool because we don't have to scatter around and look for different tools and understand what's the latest tool that we should use, which is the case, let's say, with JavaScript. In the past 15 years, many criticisms of and far more rants about Go have been written. What interested me is the idea that Go is badly designed. This is probably mostly famous put forward by two articles. I want to get off Mr. Golang's wild ride and lies we tell ourselves to keep using Go, both by faster than Lime. The latter goes further and says, and so they didn't. They didn't design a language, it just sorta happened. So I don't really think that, again, I think that it is good to write articles criticizing Go and saying what the bad things about Go are, but I don't really think that it should be said that, for example, we are telling ourselves lies about Go, because as programmer, we need to understand the pros and cons of our tools, and we need to adjust accordingly. So if we were to use a more complex language like, let's say, Rust, we would have things like enums, and then we would able to do match, and then we would have, for example, the language telling us that we forgot to match one of the cases. Things like that are good, that's true, but at the same time, Rust is a very complex language, and it doesn't provide the simplicity for working with web services and HTTP that Go provides us with. The same thing goes for Zig. Zig also has enums, and then we can match and ensure that we match every single one of the cases. In Golang, we need to do a switch statement. We go through each one of the cases, and that is more error prone. But that is not necessarily a lie we tell ourselves. That is simply we knowing what the pros and cons are of the language and choosing what's best for us when we implement something. I think this is more of a mentality of people that spend more time online debating these things or arguing on social media about these things than actually writing stuff and giving things a try and understanding that not everyone is as emotional about these things as some people are. So what is the design anyway? To me, a design is a plan or specification for something that fulfills a goal. For example, the goal of the BBC News website might be to inform users of the most relevant things that are going on in the world. The way they do that is by writing news articles, ordering them based on location and importance. The nuclear missile speeding towards me trumps the cat stuck up in a tree. It follows that a design can be evaluated on how well it achieves the design goal. And I think this is also true. If you are trying to build a simple language, that is the goal of the language. And I don't really agree with this quote up here that says that the language wasn't designed, it just sort of happened. This person that wrote this article might have a different opinion about what a good design is, but that doesn't mean it wasn't designed with something in mind and with a specific purpose. We might have disagreements about what makes a good language, but if you're trying to build a language with a specific goal in mind, it will end up being different than other languages with other goals. The genesis of Go. Go was designed at Google, where Russ Cox, Rob Pike, and Ken Thompson, and many others were working. Google was using Java and C++ at the time, which the designers of Go felt were performant but hard to use. The compilers were slow, tooling was finicky, and the languages had been designed at least a decade before. Cloud computing, large numbers of multi-core servers working together, was becoming widespread. And this is also something that is important to keep in mind. Go is very good at concurrency and taking advantage of multi-core architecture by using Go routines and then having ways to communicate between those Go routines. And was also one of the goals of the Go language. Maybe they didn't focus as much on other things like enums or having a very complex type system, and they focused more on other things like having a simple language and having very good concurrency or multi-threading. They decided to design their own language and prioritize making it work at scale in computing and manpower. Rob Pike explains in Google at Go, the hardware is big and the software is big. There are many millions of lines of software with servers mostly in C++ and lots of Java and Python for the other pieces. Thousands of engineers work on the code. Elsewhere, Pike talks about the thousands of engineers he was targeting in his usual modest, subtle way. The key point here is our programmers are Googlers, they're not researchers. They're not capable of understanding a brilliant language. Top tip, if you're designing something, try to avoid belittling and patronizing the people you are designing for. Now, I don't really agree with this quote. I understand that maybe the way that Rob Pike expressed this opinion was not very subtle, like this says here, but I agree. A lot of programmers, they are not researchers, and they are not even interested in these kinds of things. They are not interested in knowing why a language is complex and how to use all that complexity. I think that, again, people who are very much online and they argue about these things online, they end up thinking, okay, so I'm very interested in these details about programming. I'm very interested in, let's say, type systems, what makes a good type system, what makes a good language, and they automatically assume that all other developers want to also do those things. So if I like writing Rust and I like the complex type system and the borrow checker and all those things, it automatically means, right, that all other people also are the same. And that's not true at all. Other people, most web developers, I would say, just want to get their job done and they want to actually build something. They are interested in building something, but they are not interested in understanding these research level kinds of things. In my case, I am not as much obviously as other people, but I also dabble in these kinds of things and I find them interesting. But it doesn't mean that other people find them interesting as well. Now, I don't really agree that they're not capable, quote unquote, of understanding the brilliant language um, at all, but at this point in time for a particular, let's say, programmer, they are not capable, and that is not belittling necessarily the programmer. It just means that if I at this point know how to use React and I know how to use JavaScript and I know the basics of building a UI, I'm not at that moment capable of understanding the complexities of, quote unquote, a brilliant language. If I study, if I start reading things in a couple of months, in a couple of years, I might start understanding and becoming good at those things. But at the moment, I'm not capable of understanding that. And that is just a reality. It doesn't mean that people are limited in their, let's say, brain capacity to understand these things. But at the moment, that is not something that some programmers know. And again, a lot of programmers don't even care about knowing these things. And we need to be aware of that. Notwithstanding this quote, we get a pretty reasonable design goal. The language should make writing and maintaining large concurrent servers code easy, even across thousands of developers of different skill levels. So this is the thing. It doesn't mean that a beginner programmer will never understand things that are more complex, but at that point they do not, and we have to, in this case, the design goal was to have a language that more beginner programmers, or let's say people getting out of college, could understand. Go lamentations. Let's look at some complaints people have about Go and evaluate them against the design goal. First, the file system API. Go's file system API is often criticized for being geared towards Unix. Windows doesn't have file permissions in the way that Unix does, so Go just returns some made-up ones. Furthermore, Go takes a pretty simplistic approach to paths. Any OS has a path separator, and paths themselves are Go's string type, just a slice of bytes with no real checking or constraints. Other languages are more strict. For example, the Rust method to get a file's modified time can return none. In Zig, file metadata is different depending on the OS. This can be explained by the design goal. Go was designed for use at Google, where their servers are on Linux, like most servers. If you're designing a language that is aimed at servers, writing the file system API to be Unix-centric is not such a bad idea. Now, I agree with this, and if the Go documentation, I honestly never stumbled upon this problem because I mostly used Linux when I started programming, and then I switched over to macOS. And since they're both Unix, I never really encountered this issue with file permissions, and I wasn't even aware, to be totally honest, that Go just returned some made-up ones. Now, if the documentation is clear about that, then I don't really see a problem with it. And I also agree with the statement that if the goal was to build something that will be run on servers and not necessarily used to build things on the client side, then it is a perfectly normal decision. So, for example, languages like Zig are being used today to build more stuff for the computer, things that are native, for example, the Ghosty terminal, and Rust is also used a lot to build things also that are run directly on a computer. For example, the Pop OS team is now using Rust to build a new desktop environment for Linux, and both of those languages are great for these things, but I don't really think that Go is a nice language to build things on a desktop. Some people might use it, that's perfectly fine. If you like Go and if you want to experiment with Go for building things for the desktop, native applications, then go ahead and do that. But I don't really think that was the goal of the language when it was first designed. No operator or function overloading. In Go, unlike Java, functions and methods only have one definition. Once build tags and targets are specified. Operators are implemented in the compiler, unlike C++, and so cannot be overloaded either. In the time package, to add a duration to a time, you need to use the add method. If you want to add 2 days, you can't just call add and then the years, the months, and the days. You need to use add date. To some, this might seem inelegant, but it is simpler. If you see a function called in Go, you know there is one definition you need to check. If you see an operator, you know it is for a built-in type and you will do something sensible, not mint an NFT. And this is very true. When we are reading Go, we always know what's happening. It is very simple to understand what's happening when we are reading Go code. And using this kind of patterns, so relying more on functions and having, let's say, names or text inside instead of having symbols, I think is a good approach in general. I think that Rust also relies a lot on words itself, on text, to identify what's happening inside of the code instead of symbols, and I think that is a good approach. So if I'm reading code and I see add date, I know exactly what's happening, instead of saying, for example, here's a date and I'm going to add a plus sign and then another date next to it. That just makes things more confusing, and we need to keep in mind what's happening with the compiler underneath the hood and exactly how it is going to transform that. Laborious error handling. It's fair to say that the current trend in programming languages is toward terseness. No wonder programmers hate Go's if error is different than nil style of error handling. I think while it is very true that this type of error handling is, like the article says, very laborious, it has a lot of boilerplate, I think that it was overall a good choice because it is simple to read and understand exactly where the errors are, and it doesn't have, again, special types of keywords to handle these things. We have the if keyword, we have the nil keyword, and then we don't have to remember additional syntax or additional ways of doing things. This makes the language very easy. Now, it's not obviously a good choice to always pick Go for all types of projects, and I would say that in my case, I use Go for most projects because I really like using it. Obviously, not all projects that I build are in Go, but I use it for most of them. But the situations where I always pick it and where I don't even consider other languages are situations where I need something to be correct. A program needs to be correct. It cannot fail, or if it fails, I need to have some sort of logging that failure and knowing exactly where it failed. But in those types of situations, and specifically if it is in a web context, then I always go with the Go language because it is very simple to understand, it is very simple to read and write, and also to modify over time. So I have some things that are running currently in production, and I've built them with Go because there are parts of the work that I do that require things to always go according to plan, and I can't take a risk and just say, okay, so if this fails, I'm going to throw, and then if that happens, I don't even know about it. If something returns an error, I want to know exactly where that error is coming from. I want to be able to log it, to display a message, so that I know exactly at what point inside the program it erred. And as a result, it also means that I don't have any kinds of surprises. So again, while this is something that is very, very laborious, like this says, I think that once we build these kinds of, let's say, a web service that is using Go, it is important to also understand that at some point it is going to be done, it is going to be finished. We want to obviously add some kinds of features in the future, but it is important for it to be correct. And even though we are writing a lot of boilerplate, it's not necessarily the end of the world because it is more important for the program to work correctly than for us as web developers to always be as happy as we can. However, again, this was a deliberate choice. Although in contrast, Go makes it more verbose to check errors, the explicit design keeps the flow of control straightforward, literally. So, just like I said, this is my exact point, and I totally agree with this. it makes things very easy, and it is very explicit. The flow of control is very explicit. We know, okay, so I'm getting this thing, I'm calling this function, it returns an error and a value. If the error is different than nil, then we might want to do something, or we might even choose to continue running the program. We might choose to return, we might choose to ignore the error if it makes sense. It is our decision as a programmer when we are implementing things based on the requirements, but we have always this explicit way of knowing where the errors are, and also of reading the code and understanding right away where they are. Obvious control flow makes code more readable, although languages with exceptions might be quicker to write. The code they produce is not as simple, and control flow is hidden. Go is often criticized for being a bit of a throwback by avoiding features like exceptions. Someone once asked the designers why did you choose to ignore any research about type systems since the 1970s. Similar arguments has been repeated elsewhere. Firstly, Rob Pikes sees your snootiness and doesn't care about it. Go was designed to address the problems faced in software development at Google, which led to a language that is not a breakthrough research language, but is nonetheless an excellent tool for engineering large software projects. So I totally agree with this. I think that it is very, again, important for us to keep in mind the difference between people that are very interested in the nuances of languages. They are very interested in understanding what makes a good language, what makes a bad language, and they really like to get into those details and understand them. And then there are programmers that don't really care about those kinds of things, and they just want to write things. They have a project in mind, they want to accomplish something very specific, and they want a language that allows them to do that as simply as possible, so go from A to B without having any kinds of problems as a result or in the process, let's say. But secondly, designing errors as explicit values has been a trend resetter. Go, Rust, and Zig have all chosen to use this approach. Swift, even though it uses exceptions, requires you to mark functions that can err in their signature. Poor FFI story. Go doesn't play nicely with other languages. If you want to call a C function, for example to bind to SQLite, then you have to go through CGO. CGO is not Go and has a performance overhead, as Go routines, which have their own stack set up by the Go runtime, are the unit of execution. Go has to do some acrobatics to have the stack in a way C expects. This can be costly. Go's FFI is not helped by it having its own compiler, linker, and debugger. Much in the Go ecosystem is custom. So what this refers to here is Go is not very good at being able to interact with other languages. So let's say that if you build something, for example, in C, and then you are building something in C because you want that thing to either be very performant, or you already have built it in C in the past, in the case of SQLite, and you want to be able to interact with that via the foreign function interface, so FFI. And then in those cases, you want to have a way for your language to be able to interact with another language in a way that's performant without having, let's say, the overhead of calling an additional service, or for example, calling something inside of your operating system. You want to have sort of that communication happen as closely as possible and be as performant as possible. And in that case, Go is not very good in doing these kinds of things when it comes to FFI. So other languages like Zig, so I would say that Zig at the moment is the best language for interacting with C, because it shares a lot of commonalities with C, and it was also built with that in mind. So you can actually import C code into Zig and run it like it was native code almost, and it works very nicely. But again, this was not really, I believe, the goal of the Go language, and as a result, it's not really that good when it comes to these kinds of things. When we consider the design goal, we can find justification. Server software has to be concurrent, and so Go routines were chosen. That necessarily makes calling C code more complicated, but the trade-off does at least fit with Go being used for concurrent systems when servers talk to each other, not processes. These decisions also gave Go a leg up on tooling. The compiler being specific to Go means it can focus on compiling just Go as quickly as possible. The debugger can understand Go routines and all of the Go's built-in types. So if you're not aware of it, a lot of languages use LLVM under the hood to do their compiling. So this includes, if I'm not mistaken, C++, Rust, and also Zig. But Go doesn't use LLVM under the hood, and it uses all of its own way of doing the compilation. As a result, Go's compiler is very fast. If you've ever used Go to compile your code, you know that it is almost instant in a lot of projects, unless you have a very big project, and especially when compared to languages like Rust, which take a long time for the exact same thing. So if you build, for example, a CLI application with very basic functionality in Rust and build the exact same thing in Go, and you try to compile them at the same time, the Go one is going to be much faster. So these decisions, again, were made with this in mind. They wanted the compiler to be fast. But it might lead to some complications, especially like this says here, when it comes to interacting with other languages via FFI. So Go is great, that's subjective. For my part, I like it. The Go code I've looked at and worked on has generally been easy to read and understand. The lack of bells and whistles forces me to just write the damn code rather than building abstractions that don't hold their weight. And this is where Go truly shines. If you want to build something, Go is a very simple language and it will get out of the way. You can build stuff. Obviously, you need to have more boilerplate when it comes to certain parts of your application compared to other languages like dynamic languages, JavaScript for example, or even strongly typed languages like Rust. But you'll have a much nicer experience because the language is simple and you can just build something. You don't have to worry about complex things inside of the language. I've also taught Go to a large group of graduates just out of university with success. And here, in my case, on the Web Dev Fuel channel, I also teach Go a lot, and I've started to like it more and more over time, and I've been teaching it more and more also. And that is because not only do I enjoy writing Go and reading Go and building things with Go, but also because it is very simple to use it as an example to build stuff. So a lot of things that I build inside of the channel and a lot of tutorials that I record and I publish, they are built with Go. But if you take the knowledge that I'm teaching you, you can also transfer that knowledge to other languages. So if you're trying to build something, let's say with HTMX, and then you have the front end talking to a Go backend, Go is very simple in terms of writing things and building things, but also for learning, it is a very simple language for me to teach other people and to say, okay, so here's exactly what's happening. We return this error, and then if that happens, we want to return this to the front end. We want to add this header. All of that syntax is very simple to understand, and I don't usually have to go on tangents when it comes to so the language is going to actually do these things, and it is important to keep these things in mind about the language. I usually just focus on the things that we are building, and that is a very good strong point of Go when it comes to also learning and teaching. That doesn't mean I don't see its downsides. I've been sat in a call with a customer who was affected by a bug that we couldn't trace due to not checking an error. Easily prevented by linters, painful when you haven't turned them on. For ages, Go didn't have a generics, which made it annoying to write generic data structures. Every time I receive a bug report on Windows, I have to pause to think about whether Go has lulled me into a false sense of security. Ultimately, these are issues that have resulted from a trade-off that was deliberately made in the design process. You can say you don't like Go, or that it is a bad fit for a certain application, or it doesn't give you the things you need. Heck, you can even say you hate it, but don't say it wasn't well designed. And I'm in total agreement. I think that while you can say that you hate the language, I don't really think that's a very productive conversation. But if that's your thing, then go ahead and do that. But I think that it is important for us to understand the downsides. So like Matt writes here, that doesn't mean I don't see its downsides. This is a very important thing. When I write Go, I know that I'm not picking the best language ever. It is not the best language in all categories. It is not the best language to do everything under the sun when it comes to programming, but it is a very good language, and I would say the best language when it comes to building web stuff on the server. And now with the help of tools like HTMX, we don't have to rely as much on front-end frameworks to do all of the things, and this means that we can rely more on the server and build things with Go there. So if you're thinking of building, let's say, a web application, HTTP service that communicates with other services, aggregates data, and then returns responses. In those kinds of situations, I think Go is king. Go is the best language to do those things. That's my opinion. You might disagree. Other developers might disagree, but I think Go is the best language when it comes again to web stuff. And I don't really see a point in debating, again, emotionally, from an emotion standpoint, why Go is a bad language, or you're a bad developer if you write Go, or you don't really understand. You should even be writing Go or code at all if you don't understand why Go is bad. I've seen all of those arguments being made on X, and I think it is not a productive conversation. It is much more productive to lay out what the pros and cons are, but to make assumptions about other developers' knowledge of writing code, or their, let's say, their intelligence, because they don't see a point in writing other languages like Rust or Zig for the use cases. I don't really think that's good at all. So this is it. I hope that this video was helpful to you. Again, I'm going to leave a link in the description down below to the article if you want to also give it a read. And I'll see you on the next one.